Okay guys, I wanted to talk to you a little bit about your polar project and what all you needed to do for it. When you look at the actual assignment, you'll notice that the bottom of it there are a couple of examples for you to look at. Both of those examples are done in degree mode, whereas most of everything else you've done has been done in radian mode. It is your decision which mode you want to be in. I would recommend, if you're in degree mode, follow like the first example where it has the theta sub 5, and if you look at the table, the theta counts by 5 each time. Put that in as your theta step when you go to your window settings or your table settings. From there, if you are going to be in radian mode, I would recommend that you put your theta step as pi over 24. When you're looking at your actual graph that I give you, each of those lines, if you look at it, is actually pi over 12, but by using pi over 24, yes, you'll have those in-between dots to plot, but it'll be a little bit more exact. So that would be a little bit better for you to do. Yes, you have to color it. Yes, you have to write down your equations on your paper. Yes, it needs to be precise. And yes, it needs to actually look like what you say it is. So if you're going to call it some sort of flower, it should probably look like a flower. Hold on. I also shouldn't be able to Google your exact equations and get the exact same thing that you have. It needs to be unique. I will be using my calculator to match your settings, so make sure you have all of your window settings on there and you have your equation written down exactly as it's supposed to be. And then if you need to color your graph to add something in to make it look a little bit more whatever shape you have decided, that is totally fine. So I wanted to show you a couple of examples. This is the polar plane that I had someone do last year. Almost every single one of those lines comes from her graph. Now the window, if I recall, does not, the front windshield, if you will, and the fin on top doesn't, but the blades, the kind of spiral in the middle that shows that it's spinning, the wings itself, all of those do. Here's another one. This is a hot air balloon. Okay, yeah, she added in the stripes to make it look more like a hot air balloon, but just by graphing it, I can tell what it looks like. I see the picture. And yeah, she added in the clouds to make it look a little bit more like that as well. One thing that's kind of neat that she did is she has these graphed right here. There's like these little arcs. So what she said was, what she couldn't get on her calculator, but I could graph it on my paper, is she said, oh, I'm going to graph r equals 3. I can't remember exactly where that one is. Or r equals 4, but only between whatever these two angles are. So that would cut off my graph, and I would know only include those circles from these pieces. So on her actual calculator, those circles went all the way around. But on her picture, she told me, and on her window settings, she told me to only do that for those regions. Here's another really cute one, a bumblebee. Okay, yeah, she had to add the stripes of the bee and the antenna, and of course like the eye and the mouth to make it a little bit cuter, but most of that was already on there for her. And then one last one, the polar penguin. Now he's been colored rather dark. Hard to see a little bit on my camera, but you can see where the actual outline where she followed the graph of the stomach, the face, and the entire penguin there is bolded, because that lets me see where the graph actually shows up. Also, for some of these, like the wings, she may not have used an entire equation, or like things overlap. So when I graph it on my calculator, I see multiple things that I may not see actually on the picture because of the way she colored it. But I can still see a general shape of a penguin on my graph, and then I see a very cute penguin on here. If you have any questions while you're doing it, make sure you ask. I'm not going to tell you an equation to use. I'm not going to tell you how to do your equation. I'm not going to tell you what to do. That's on you. But I will help if you're saying, is this okay? Can I do this? I definitely shouldn't see any that look like the ones that I just went through with you, though. And I shouldn't see the same one multiple times in a graph. I will say one of the more common ones is a flower. I don't expect to see more than one flower from each class. And if there are multiples, those people will lose points. So make sure you are making it unique.